All right, welcome. Today we're going to talk about multiplying polynomials. We're really going to be multiplying a monomial, which you should know what that is by now, times a polynomial. Our goal is to perform multiplication on two polynomials. It shouldn't take as long as this guy over here. Let's go. So a quick recap, what is multiplication? Example, 3 times 4. We should all know that real quick. That's 12. But what are we actually saying? We have 3 4 times, right? So multiplication is repeated addition. 3 plus 3 plus 3 plus 3 is 12. Here we have 6. The same is true with our polynomial multiplication. It's just easier to do the multiplying instead of write this out. That's why we do multiplication. It's faster than writing out repeated addition. This is just to clarify. This is probably a review for everyone. Let's keep moving forward. So, multiplication of variables and monomials. So we have a variable here, okay? So I have 2x times 4x. This is really 2 times 4 times x times x. I'll just write it all out. Multiplication order does not matter, it's commutative. So I have the two coefficients, right? 2 and 4. I multiply them together and I get 8. And then I have the two variables. They both have an exponent of 1. So I multiply the x's together. I'm adding the exponents. Whoops, I skipped ahead there. And that gives me 8x squared because 1 plus 1, that's a 1. 1 plus 1 is 2. Okay, this is how we multiply. These are two monomials. And we multiply the coefficients together, and then we just multiply the variables, adding the exponents where the bases are the same. Multiplying polynomials. Here we have a monomial of degree 1 times a binomial of also degree 1. A, B, and C are integers, and we're just going to use x as our variable. This is a very basic general example. But before we use the general example, what does this look like with just numbers? So let's say I have 6 times, and then parentheses, 10 plus 4. We just broke apart 14, so we can use an example like this, okay? That is the same as 6 times 14, which equals 84, okay? This is a straightforward multiplication problem. What would it look like if we distributed instead 6 times 10, 6 times 4? Well, let's see. You can see here we distributed 6 times 10 plus, because they're both positive, 6 times 4. We get 60 plus 24, which equals, oops, it doesn't equal a red arrow, equals 84. These are the same. So distribution just helps us do some multiplication sometimes a little more simply. We're going to see it in practice with some sample problems moving ahead. All right, we have a sample problem. These are problems that you will most likely see. So let's just write it out. Distribute it first, okay? I have 4x times 3x plus 2. I'm going to distribute the 4x inside. So I have 4x times 3x plus 4x times 2. I'm just writing it out, okay? 4x times 3x is 12, 4 times 3, x squared plus 4x times 2. 2 is a constant, so I just multiply the numbers together, 8x. And I'm done. I cannot simplify. I cannot combine 12x squared with 8x because while the variable is the same, the power, the exponent, is not. So I can only add them together if the exponents are the same. And we're done. Here's a sample problem that's a little more involved. 2 times x squared times y, so 2x squared y, times parentheses 3x squared plus 4y. So we're going to distribute this monomial into this binomial. As you can see, I rewrote it, distributing our monomial into the binomial, and this is what we get. 2x squared y times 3x squared plus 2x squared y times 4y. And once I do the multiplication, I multiply my coefficients, the number in front of the variable. 2 times 3 is 6. I multiply the variables that have the same base, and so then I'm adding the exponents. So x squared times x squared is x to the 4th. Y times nothing, this is y, like times 1. Is just y, so the y just comes down. It doesn't have anything to multiply to increase its exponent. Same thing here, 2 times 4 is 8. X squared times, there's no x there, so it's just x squared comes down unchanged. Then I have y to the 1 times y to the 1, it's y squared, all done. This one's even more involved, but we're going to follow the same process. We have a monomial of degree 5 times a 4-term polynomial of degree 1. The highest exponent here is 1 for any term. So we are going to do the same thing we've done. To keep things visually organized, I'm using some different colors for each term in my polynomial. So the first term, second term, third term, and the fourth term. So I've showed my distribution here. So here's the monomial times the first term, monomial times the second term, monomial times the third term, and then the monomial times the fourth term, which is a constant. So we're going to do the same thing we've done. We're going to switch back to all one color here. So here we've done. I've done all the multiplication. 8x cubed y squared z plus 6x squared y cubed z plus 4x squared y squared z squared plus 18x squared y squared z squared. That's a mouthful. Now you might be wondering why I'm not combining terms. Each of these 4 terms has x, y, and z. They all have the same variables. And 3 of them have the same power, or degree. This is a degree 6. 3 plus 2 plus 1 is 6. 2 plus 3 plus 1 is 6. 2 plus 2 plus 2 is 6. And 2 plus 2 plus 1 is 5. So this is of degree 5. Okay. The reason we cannot combine them is because each variable has to have identical exponents with another term to add together. So here we have a 3 for my x cubed, and this is an x squared. So I automatically cannot add those together. Okay, I have an x squared here and an x squared here, but I have a y cubed and a y squared, so I cannot add these together. And finally, I have x squared, y squared, which matches this one, but I have a z squared, and this is z to the 1, so I cannot add these together. This is my final answer. This is simplified. There's nothing more we can do. Recap. We are using the distributive property, and we're going to be using it a lot. Spider-Man, what do we use? Distributive property. Okay, what does that look like? Here I have the general form of the one we just did, where a, b, c, d, and e are just integers, and I have some variables, x, y, and z. These are my variables. When I distribute this ax through this 4-term degree 1 polynomial, and it could be any number of terms, any degree polynomial on the inside, it does not matter. I multiply the coefficients together, and then I multiply the variables together using the exponent rules that we have learned. So you see a times b is right here, a times c is here, a times d is right there, and then a times e is here. And then I'm just multiplying the variables, x times x, x squared, x times y, x times y, x times z, x times z, x times the constant, and it's just x to the first power. Your assignment is another worksheet. Here's the title here for those of you who are my students. If you have any questions, you know how to get a hold of me. I hope this has been helpful. Remember what Spider-Man says when we're multiplying polynomials. Good luck.